Alright guys, today we're looking at the product rule of exponents. So the product rule of exponents is just a rule that when you multiply like bases, you add the exponents. So when you're talking about bases and exponents, the base of an expression or an exponential expression is the actual value, so x or a number. The exponent is the smaller piece that you see up at the top. So this is x squared, where x is the base and 2, the square, is the exponent. Okay, so we're going to look at some examples here. In example 1, we have 2 squared times 2 to the 4th. Our bases are both 2, which means when I'm simplifying this, this becomes 2 to the 2 plus 4 power, because when I multiply like bases, I add my exponents. The base doesn't change. 2 times 2 does not become 4. We're just keeping our base the exact same. It's still 2, and then I take my exponents, which are 2 and 4, and I add them. So this becomes 2 to the 2 plus 4 power, which is 6. And if you're trying to simplify this, you would want to actually go ahead and write that out. 2 to the 6th power, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 2 to the 6th power is going to be 64. In example 2, my bases are both x, and one of my exponents is 3, and it doesn't look like I have an exponent on the first x, but remember, if an x is there, that means there is one x, or x to the first power. So the exponent on the first x is 1. Even though you didn't originally see it, it is still there. So this is going to become x to the 1 plus 3 power. Remember, we keep our base the exact same, and we add our exponents together. That's what happened. So this becomes x to the 4th power. There's nothing left to simplify, so we simply box it up. In example 3, I have 2x times x to the 4th times y. So first of all, I have like bases of x and x to the 4th. The 2 that's attached to the x, that's great. It's there. Don't worry about it, though. It has nothing, in this case, to do with x. So we don't have to say that 2x and x are not like bases. They are. They both have x. 2 and y are not like bases. So all I'm going to do is bring them out front, and I'm going to say that this is 2 times y times my base x, okay, my base x, and then remember I have that little invisible 1, so my two exponents are 1 and 4, so I'm going to go ahead and add those, 1 and 4, so x to the 1 plus 4 power. So this is going to become 2y x to the 5th. 2 times y times x to the 5th power. Remember, we're adding our exponents. In example 4, here's my like bases. I have an x, and I have some 2's. So I'm going to put the 2's together with their exponents. The second 2 has an exponent of 1, and so does the second x. So this becomes 2 to the 4 plus 1 power times x to the 3 plus 1 power, which will simplify to 2 to the 5th times x to the 4th. And 2 to the 5th power is 32. So this becomes 32 times x to the 4th power. In example 5, I have a few like bases. I have -3 and -3. It's both of them are to the first power, right? So this would be -3 to the 1 plus 1 power. Then I have m to the fourth and m to the fourth. This becomes m to the 4 plus 4 power. Then I have p but no like base, so I'm just going to write it down right beside it. This becomes p squared, and there's nothing to contribute to that. So this is what we have. I have negative 3 squared times m to the 8th times p to the 2nd. And negative 3 squared is going to become 9 m to the 8th p to the 2nd power. In example 6, I have 4a squared b squared times 3a to the 4th b to the 3rd. Okay, so I don't have, as far as numbers go, I don't have like terms, but I can still take 4 and 3 and multiply them. So I'm going to have 4 times 3 out front. Then I have a as a base here and here. So this becomes a to the 2 plus 4 power. Then I have b as a base, and b has an exponent of 2 and 3. So this becomes 12, that's 4 times 3, a to the 6th, b to the 5th. Alright guys, that was the product rule of exponents. Have a great day.